Welcome back to your next round of video notes, THS Chem Team. And this topic we're going to be covering or starting is going to be bonding. So it's a quick introduction to bonding. So get your periodic table in front of you and open your notebooks up so we can get started. The chemical bond is when we have an interaction between atoms. And this interaction actually causes them to stick together or have an interaction where they are going to be moving as one combined unit. And so the interaction actually happens between the valence electrons of those atoms, and it acts like a glue between the atoms. So they get stuck together. And the reason they go through this is that they're trying to follow an octet rule. An octet rule is just a different way of saying that they want to become stable or have a complete valence shell. So we've heard this term before when we were talking about all of these guys over here on the far right of the table, the noble gases. So when atoms bond, the whole point is that they want to be like the noble gases. Now, we call it the octet rule, but that generally is going to tell us 8 valence electrons. However, there's a few situations where it's not going to be 8. For example, if we were looking at all of our noble gases, we know that helium technically is a stable and complete octet, even though there's not 8 electrons there. It only has 2 because it's in the first energy level, but it's still considered a full valence shell or a stable octet. So atoms will either lose or gain electrons to be like these noble gases. And we already know that we have our staircase running through the table here, and this is our dividing line. So we say that atoms are willing to gain or lose. We're talking about metals and nonmetals. So if we were to look all the way over on the left-hand side of our staircase, we know that that's where our metals are. And metals, we know, have that low ionization energy. And that tells us that it is relatively easy to remove their electrons. So we talk about gaining and losing electrons. Metals will lose their valence electrons to become stable. And the number they lose is the number they need to get back to be like a noble gas. All right, and nonmetals all the way over here to the right of our staircase, including hydrogen, is considered a nonmetal. Nonmetals will gain electrons. And the reason they do that is that they have a high electronegativity. And we know that electronegativity is just a measurement to say how badly or how easily they can gain electrons. And we know that nonmetals, our trend is as we go left to right across the table, that electronegativity increases. So our nonmetals gain electrons to be like a noble gas and get that stable octet. Metals will lose electrons to get that full, complete valence shell, like the noble gases. All right, there are 3 different types of bonds. And the first one we're going to talk about this week is going to be an ionic bond. And an ionic bond happens between a metal and a nonmetal. So if we have a metal all the way over here from the left side of the table and a nonmetal from the right side of the table to the right of the staircase, and they want to interact, they're going to form what's called an ionic bond. And an ionic bond between a metal and a nonmetal is a transfer of electrons. So the key word there is transfer, and this comes up quite a bit. So a transfer of electrons, think about what we just talked about when we looked back at the other table. We know that anything to the left of our staircase, the metals, that low ionization energy, are willing to lose their electrons to become stable. And nonmetals to the right of our staircase, the high electronegativity, are willing to gain electrons. So if you put one together, one with the other, the metal will lose its electrons or give them away to the nonmetal, and a relationship where both can become stable and reach a full octet. Another way that you can measure this is if you were to look at their electronegativity difference. So if you were to actually compare the electronegativities of your metal and your nonmetal, if you have an electronegativity difference greater than 1.7, that means that it would be considered an ionic bond. So if you're ever confused and you're not sure if you can remember metal versus nonmetal, if you were to look up their electronegativity difference between them in your reference table, and and you subtracted them, and you had a value that was greater than 1.7, that would tell you that you have a ionic bond that would occur between those atoms. And generally speaking, the metals over on the left have a very low electronegativity. The metals on the right, very high electronegativity, so you're going to have a large difference of greater than 1.7. The next type of bond is called a covalent bond. And a covalent bond happens only between nonmetals. And the key word here is, you got to think, we said that the nonmetals all want to gain electrons. So if you put two nonmetals together, neither one is really willing to completely give up control of its valence electrons, but in certain situations, they will share their electrons. Since they're not willing to transfer or give away their electrons, if you put two together, they can share their electrons where they'll be controlled between the two atoms. And this happens only when you have nonmetals that are bonding together. Again, they're still sharing to reach a stable or complete octet, so they can be like a noble gas. And this happens when you have an electronegativity difference when your electronegativity difference is less than 1.7. And we'll actually break this down later next week when we get into polar versus nonpolar bonds, but for today, a covalent bond is when we put only nonmetals together and they bond. They're going to end up, the key word would be sharing their valence electrons. And our last type of bond is a metallic bond. Metallic bond, just like the name entails, is only going to have metals. You don't have to worry about electronegativity difference because it's only metals. The key words that are going to come up, and we'll talk more about this later, but the key words that come up is that you're going to see what's called a sea of electrons. That sea of electrons, you have a whole bunch of metals that are willing to give up or lose their electrons. If you put them together, you end up with a sea or pool of these valence electrons that can be shared or transferred between all of the metal atoms. So it's kind of a cross between a covalent and an ionic bond, and it gives metals their unique properties, such as being malleable and being good conductors. So there's your basic intro into the three types of bonds. Bring any questions to class. We'll build upon ionic bonding specifically this week. Bond out.